Building the Mirage 2000 version 70mm ducted fan with retractable landing gears. Hello, here Victor. I am a mechanical engineer and an enthusiast model airplane builder. In this video, I will present you the construction of the Mirage 2000 and some construction techniques. I hope you enjoy it. Let's start. For those who want more technical detail, here are some of them. You can pause the video for reading. I always start with the three views of the plane and scale to obtain, in this case, a wingspan of 960 mm. From there, I deduce all the other dimensions. For those who want to know how to scale from any drawing, there is a video on my channel. I didn't take pictures of each step, so I'll try to explain the construction in words. I decided to build the two-seater version of the Mirage 2000 and not the single-seater. For the base of the wing, I used Depron 10mm thick because that was the one I was able to get. I also got 3mm. The landing gear is placed 100mm behind the center of the gravity line, which is this one. To fix the wheel, I use a sheet-of plywood held between the two carbon fiber tubes. The front fuselage, as you can see here, is a simple box made with 10mm Depron. Here, the front fuselage box already placed. This is the box for the EDF unit. The size is determined by the diameter of the EDF unit. For those who want to select an EDF, there is a video on my channel for it. This is the ducted fan unit used for this project. It is Dr. Max from Habikin, 70mm diameter, 10 blades, 1750 watts, with a maximum thrust of 2,700 grams, claimed by the manufacturer. According to my measurement, the actual thrust is 2,270 grams. This EDF is fixed in the fuselage using plastic bases made from recovered containers. I use two carbon fiber tubes for reinforcement, and here is the sidewall of the air intakes. This area exceeds the ducted fan area by 25% at least. The air stream is direct to the EDF unit, which is placed in the rear fuselage. The nose cone is made with overlapping sheets of 10mm Deprons. Here, adapting the nose cone to the fuselage. Placing the top cover for the ducts. The leading edge of the wing is reinforced with wooden rods. These wooden rods give it a rounded edge and also give a great resistance to the wind. To prevent air from entering the wheel voids, I covered these gaps with plastic chips and covering paper. The joint of the elbows are made with cover paper, which already comes with glue. Here, one of the main landing gear already installed. This is a lower view of the main gear. Here, the entire lower surface of the wing is lined with mosquito net mesh which is fiberglass. This is the front opening in the fuselage for the retractable nose wheel. The nose retractable wheel is suspended in the front of the fuselage by plastic bands made from discarded plastic containers. This is a view from below of the front landing gear. The wooden sheet here serves to reinforce the joint between the front fuselage and the wing. Due to the special shape of the top cover of the fuselage, I use a paper pattern to mat over the apron later. Here, adapting the top cover of the fuselage to the main fuselage. A pattern in the apron 10 millimeters to build the canopy. I cut these filler pieces here to make the canopy. Here grouping all the filling pieces together. And the canopy already sanded, molded. Placing the vertical stabilizer, which is reinforced with a wooden rod on the leading edge here. And I use the exit cone to recover from another plane. Making a paper pattern for the top of the wing, which will be in 3 millimeter deep round. To give the curvature of the upper wing cover, I use F1 base shown here. This is the cover for the batteries. The upper wing cover is glued back here and forth here, and near to the fuselage is attached with cover paper. This is what the wings look like with the top covers in place. I place the receiver at the front fuselage on top of the front wheel. Here we can see the EDF unit already installed, and this phone is to prevent that the EDF from sucking air from the back. And here is this 100 speed controller. The exit tube is constructed of paper coated with transparent plastic tape internally and externally. It gives a smooth surface. The exit cone is removable using 3 screws. Inside this cone is placed the tube to direct the air from the ducted fan to the exit. To allow belly landing, I place the control rods of the aileron on top of the wing. A view of the model assembled before painting. The entire top is removable through the use of a small screw that we will see later. Here the model painted with a camouflage pattern. I use water-based acrylic paint and then water-based acrylic enamel as well. The white lines or the canopy are made with paper and then glued to the canopy. An upside down view to show the landing gears. By removing the top caps, I can have access to the entire internal part of the aircraft, which is excellent for assembly and maintenance. Note in the upper cut that the openings whisk grill for the cooling air intake of the speed controller. Here is a short video of the model taking off and flying. If you liked this video, give it a thumbs up and subscribe to the channel. See you in the next video.